Now we're going to analyze the plate. So after it has been, as soon as you got to watch it, make sure that the what is called the solvent front, which is the front of the solvent, how far the solvent has traveled, does not go beyond, of course, the edge, the top edge of the plate. So I stopped it. If you look over here real quick, I made a mark as to where the solvent front was because it evaporates really quickly. So the first number that we're recording is going to be what is called the solvent front. So it's going to be from this line to the mark, and that's 8 centimeter, which is 80 millimeters. Okay, so this is Ashley's, right?
Yeah.
I'm going to write it on here. Okay, so it is 80 millimeters. That is the solvent front. Don't worry, I'll share the numbers with you guys. Now, this is the carotene. It tells you that the yellow-orange one is the carotene. Well, we know that because that was the carrot. That's the control. That's not what we're after. What we're after is the other one here. So I'm gonna put a mark where the bands are. Here's one. Here's another one. Here's another one. Here's another one. If you look really, really, really close, you might want to come up here a little bit. There's a gray one right here. You see that gray one right there?
Mm-hmm.
That's broken down products of chlorophyll. We don't count that one. This gray one right here. You want to come up here to see it?
It's going to be hard for them to see it.
That's going to be hard to see, yeah. That's fine. Anyways, we don't worry about that because those are just broken down products. So then we're going to measure the distance for each one. So the distance of this one is 74 millimeters. Fastest spot was 74 millimeters. Next one is 30 millimeters. Next one is 28. All right. Next one is 18. They give you an extra line, that's fine. Okay? So now, here are the values: 80, 74, 30, 28, 18. Based on the distances traveled from the line that we drew to where the band is, or to where the solvent front is. Now, you have to calculate the RF value. To do that is very easy. It is always going to be the distance of the band divided by the solvent front. So for the first one, it's going to be 74 divided by 80. That will give you a number. The second one, it'll be 30 divided by 80. 28 divided by 80. Can you guess what the last one is? 18 divided by
80.
80 again, right? It's always the distance of the band traveled, distance divided by the solvent front. That gives you what's called the RF value. The other thing is the color. This one is if you look at the key here, the top band is the yellow-orange. So, yellow-orange. The second one is the blue-green, this one. Blue-green. The third one is the yellow-green. Yellow-green. And the last one is just the yellow one. This last one right here. The colors start fading over time. So now, from the color designations, you can tell from this key which pigment it is. You see that? So when you go and watch the video, you can use that as your guide here. Again, from the color, you can tell which pigment it is, and that's what you record over here. But you should also record the RF value. See, obviously, the bands, the migration of the bands are different. This is so difficult to take off there. The migration of the bands are different. This one moved faster than this one. But if I told you, for example, this one moved 74 millimeters, and this one moved 30 millimeters, you get this question in your mind, compared to, with respect to what? You have to standardize it against something. You say, it moved 74 millimeters with respect to the solvent front. You see? It moved 30 millimeters with respect to the solvent front. You always have to say, with respect to something. Because if I say it moved 74 millimeters, that means nothing. But if you look at it, 74 millimeters versus the 80 millimeters of the solvent front, that tells you something. That it's moving almost with the solvent front. That means it's what? High polarity or low polarity? There you go. That's what it means. So if I say it moved 74 millimeters, that you don't know how far the solvent front went. And you don't know how long this plate is. You see what I mean? It tells you where the band is, but in comparison to what? The solvent front is 80. That tells you, wait a minute, it's almost right on top of the solvent front. That means there's nothing attracting it to the plate, very little attracting it to the plate, right? That means it's probably low polarity. That's what that means. Okay, let's do the other one. The band that's all the way down here, it's going 18 millimeters compared to the 80 millimeter solvent front. That means what's happening to the band? It's hanging on to the plate, right? The solvent is having a very difficult time to get it to move. That means what? High polarity or low polarity? That's what it means. So you cannot just go by the number. You have to go the distance traveled divided by the solvent front. That's what the RF means. So let me do it a different way. If I tell you that the RF value of this pigment is 0.98, what does that tell you about the pigment? Is it high polarity or low polarity? What is it?
Based off the 80?
No, forget about the 80. See, I'm trying to explain to you what RF means. If I just say, well, you know that the RF is the distance of the band divided by the solvent front, right? Okay. If I say the RF is 1.0, would it's like running with the solvent, right? What's 80 divided by 80? 1. So if I say that the RF value is 1, that tells you something. Oh, that band is running right with the solvent. That means it has no polarity. You see what I mean? It's not sticking to the silica at all. You gotta, listen to me please. You gotta catch this one. This is one of the most difficult things about this here. I mean, the setup is easy, the idea is easy, but when I ask them, what does an RF value of 1 mean? No one knows. So watch out for that. It looks like it's on the exam. An RF value of 1 means that the distance of the band traveled divided by the solvent front is the same. 80 divided by 80. That means the band moved with the solvent front. That means it has what? No polarity. Yeah, it has no polarity. But if I say 0.98, that means it moved almost with the solvent front. So it has some polarity, but not a lot. Versus this one, the RF value is 0.1. That would be similar to this band. When you calculate 18 divided by 80, you're going to notice that it's going to be closer to 0 than it is to 1. When you calculate 74 divided by 80, it's going to be closer to 1 than it is to 0. You see what I mean? So an RF value of 1 would indicate the band is running right with the solvent. That means very little, if any, polarity. Thank you.